Section 1.1 angles. Objective: to define basic terminology, degree measure, standard position, and coterminal angles. Anchors: M11C 1.2, R11A 2.2. Let's start off by talking about basic terms. This will look very familiar because geometry is a prereq for the trig class, so we're going to be taking a look at some basic terminology. This will go a little quick. Two distinct points determine a line called line AB. And we recall a line has no depth or thickness. It can be called line AB, line BA. It is never ending. So it also can be written as BA or AB. Line segment AB, a portion of the line between A and B, including points A and B. You can still have it drawn just like the diagram above, and we could also determine that to be called segment AB or segment BA. A ray is a portion of a line AB that starts at point A and continues through B and on past B. So we could still use the diagram above, but the points we're really concerned are from point A continuing to point B, and all points continued past point B. That can only be called ray AB because you are going to be calling ray AB because A is the starting point. This cannot be determined by ray BA. That is another set of different points. An angle is formed by rotating a ray around its endpoint. The ray in its initial position is called an initial side of the angle. In trig, this is very important to understand where we start our angle at, especially when we get into a unit circle. And we also need to know where the ray is going to end at. Therefore, that is in a location after the rotation. That is a terminal side of the angle. So an important part of trig is to know where our initial side is and where our terminal side is. That will become very important when we get into the unit circle. A positive angle is formed when the rotation of the terminal side is counterclockwise. As you can see, our terminal side is in a position that was formed counterclockwise from our initial side. A negative angle, that's the rotation of the terminal side, which is clockwise. You can see that this is our negative angle because the terminal side was rotated rotated clockwise. The most common unit of measure for angles is the degree. And in geometry, you went through a lot of concepts that had a lot of different types of angles. We're going to get into a lot more in trig, but we're going to start off with still some basic ideas of angles. The acute angle, which means that is going to fall between 0 degrees and 90 degrees. The right angle, which is a 90-degree angle. An obtuse angle, which is between 90 degrees and 180, and the straight angle, which is 180 degrees. This should be very familiar to you since this followed through almost all of your geometry class. Let's continue with some other terminology. Complementary angles. The sum of two angles is 90 degrees. In this situation, we know we need two angles that add up to 90. The diagram below shows two adjacent angles. In this situation, they are adjacent, but they don't need to be. To solve this problem, remember, what they're asking for is the measure of each angle. Not only do we need to solve for the variable, but we also have to remember to solve for the problem that is being asked, which is to find the measure of each angle. To continue to do this, all we need to do is combine the two expressions. And since this is complementary, we know they add up to 90. Simplifying the expression, and then solving for k. Dividing by 2 will give us our solution for k. And in this situation, that'll give me 43. Now that I've already found the value for the variable for k is 43, all we need to do is substitute into our expressions that represent the angles, and then we'll find out the degree of each angle. In this situation, 43 plus 20 will give me 63 degrees. Knowing that these are complementary, all I really need to do is take 90 minus 63, and that will give me the value of the other degree, of the other angle, which is 27 degrees. Or I could actually substitute into the expression 43 minus 16 and still get 27 degrees. Let's continue on with supplementary angles. The sum of two angles is 180 degrees. As you can see in the diagram, this is a straight angle, so we know that it does add up to 180 degrees. The angles are adjacent, but they don't need to be. So in this situation, all we need to do is, again, we're going to add the two expressions together. But since they're supplementary, they will add up to 180 degrees. Simplifying the left side of the equation, and then solving for our variable. And here, our variable is going to equal 19. Again, all we need to do is substitute into the expressions given for our angles, and that will give us the degree of each angle. And here, this will give us 57 plus 2, which will give us 59 degrees. After finding that this is 59 degrees, all I need to do is subtract that from 180 degrees, which will leave us 121 degrees for our other angle, or I can substitute back into the expression to get the same answer, and that would look like this, which is 114 degrees, plus 7, which again is 121 degrees. We've already discussed that angles are usually measured in degrees, but what we didn't discuss is that they can actually break that into smaller units. And what they do here is break this into degrees, minutes, and seconds. And here is how it breaks down. 1 minute is 1/60th of a degree. Therefore, this is represented by a 1 with the little tick right here. That represents 1 minute. And that is 1/60th of a degree, or 60 minutes is 1 degree. 1 second is 1/60th of a minute. And the representation of a minute is the double tick mark at the top right. And that is 1 degree 1/60th, which is 360th of a degree. And that is received by getting 60 times 60 to give us 1 over 3,600. Or 60 seconds is 1 minute. Now what we're going to ask you to do is perform some operations in adding and subtracting degrees, minutes, and seconds, and then converting them back and forth. This is the first one that we want to look at, which is to actually find the sum of 27 degrees and 34 minutes plus 26 degrees and 52 minutes. So let's see how we're going to do this. What we need to do is to stack these on top of each other. And we're going to find the sum. I want to remind you that we need to stack the units over the correct units. So here we have stacked 27 degrees over 26 degrees, 34 minutes over 52 minutes. Then we just add them as normal. To the right, we're going to have 86 minutes. And for our degrees, we're going to have 53 degrees. But like in any other math situation, what we need to do is actually simplify. In this situation, 86 minutes, we know we can break that into 60 minutes and 26 minutes. But we already know that 60 minutes is equal to 1 degree. So what we'll do is add 1 to 53 degrees, giving us 54 degrees and 26 minutes. Now we've found the calculation for the sum of these 2 degrees, and we've also simplified it. Let's take a look at another example. Here we're going to do a difference with 2 degrees. So again, we're going to stack them, 72 degrees, and we're going to subtract 15 degrees and 18 minutes. As you can see, we have a unit to the right on our lower set here, so what we're going to have to do is borrow. And what we're going to do is take 1 degree from our left unit, giving us 71 degrees, but we know that 71 degrees with 1 degree left over gives us 60 minutes. We're going to use that for the difference for our minutes. So once we borrow again, that'll give us 42 minutes, and then we'll just use this as a subtraction. So this will give us 56 degrees, 42 minutes. Another example with a difference is going to represent us giving us a little bit more borrowing. So we're going to do this in the same fashion where we're going to stack them. 80 degrees minus 36 degrees, 18 minutes, and 47 seconds. So we're going to have to do some borrowing to get this thing resolved. So we're going to take 1 degree from 80 degrees, making that 79 degrees. That's going to give us 60 minutes. I wouldn't have written that except for this example, because what I'm going to have to do is borrow from our minutes. So this is really going to be 59 minutes, and this will give us 60 seconds. So if I found the sum all the way across the top, that would give us 80 total degrees. Now what we're going to do is just subtract as usual. Borrowing is going to give us 13 minutes. Subtracting the next set is going to be 41 minutes, 13 seconds, excuse me. And then for the degrees, so our final answer is going to be 43 degrees, 41 minutes, and 13 seconds.